Hello, class of 2018. Today we are looking at understanding the difference between population parameters and sample statistics, making sure we understand what bias means in sampling, and choosing a random sample successfully. Here are some keywords that you need to know. The entire population is the whole group from which data could be collected. Think of it as the universal set for the data that you have. If you collect data from the whole population, it's called a census. The analogy is that a sample is a subset or a part of the population from which you take a survey and you try and find out your sample statistic to approximate your population parameter. For example, you might like to determine the real average height of Australians aged 25 to 35. The parameter is the real average height of the whole population. The statistic will be the average height of the people in the sample, which could change. We often take samples because census is usually very expensive and takes a lot of time. For example, we have a 10-yearly census that the Australian government takes of everybody. So that only happens once every 10 years because it costs so much money. When you take a sample, the best kind is random sampling, which means every member of the population has an equal chance of being chosen. A special kind of random sampling is called stratified random sampling, which means you're choosing from parts of the population in the same proportion to the real group of the whole population. For example, year levels in a school. A good way of doing random sampling is to use a random number generator. If you have a small number of population size, you could even draw numbers out of a hat, but that rarely happens because your population is usually not that small. To generate random numbers, you could go to your CAS, menu probability random seed, and then you put in a number yourself, or you can generate a random number between 0 and 1, or you can generate a integer value between A and B, depending on what you tell it. Bias in sampling is not good. That means that not everybody in the sample has the same chance of being chosen. For example, you could stand outside a shopping centre and take a sample of people who are walking out, but that's not a fair sample. It's going to be biased for the people who have gone to that shopping centre. Cluster sampling is exactly the same situation I've just described, where you're looking at a localized area or an interest group. Another way of finding bias in sampling is, for example, maybe you might choose people who are a particular height and below, and they're not going to represent the whole population, for example. Population proportion P is a constant. It's completely dependent on the population. The sample proportion P hat is not constant and varies from sample to sample. So in this example, you're asked to assign numbers to this list of people and randomly choose 5 of them. It's the equivalent of having all these names in little bits of paper in one hat, and then you could have a number of numbers on, let's see, I think there's 13 of them, so you could say 1 to 13 in another hat, and then when you pull out the person's name and then you can match up the numbers with the name that you match up with. So that's one, and it's basically what you're doing, except you're using a calculator to do the work. So let's say you generate random numbers and you make Denise a 1, Sharon a 5, Miller a 9, and so on. And so let's say we generated all these numbers. If you generated some random integers 4, 19, 2, 9, 13, and 14. So far we have Miller, Tom, and Shakira. And then we still need 2 more. And then when I hit more random integers, I get to 3 and 11, which means I can choose Jai and Sanjay. Those are my 5 random choices. All right, so here we have a question where you're given a percentage and you've got to figure out whether it's the population proportion or the sample proportion p hat. You got to read this question very carefully. So in a certain school, 35% of the students travel on the school bus. So that says to me that the proportion is 35%. That's for the population. A group of 100 students was selected in a random sample, and 42 of them travel on the school bus. So, in the random sample, we have n is 100, and the sample proportion is 42 out of 100. So we call that p hat, which is 0.42. So to answer the questions, part A, the population is all the students at the school. Part B, the population proportion is P, which is 0.35. And part C, the sample proportion is 42 over 100, which is 0.42. Now, a researcher wishes to sample 50 students, so that will be our N, at random from a school containing 1,000 students. If he speaks to all the class of year 7s, do you think this will be representative, and explain? And how do you suggest the sample could be chosen? So, hopefully it's quite obvious that year 7s is only one year level out of 6, assuming it's high school, and so it's not going to be representative of the whole school. Assuming, of course, that the whole school is made out of more than just year 7s. If it is just year 7s, then it would be a fair choice. How could you suggest that the sample could be chosen? You could choose random numbers, or random number generators would be a good one. Or you could use stratified random sampling, which means that you would choose the correct proportion of students from different year levels, depending on how big their year level was.